String operations and text cleaning in Pandas. Let us explore how to clean and manipulate text data in Pandas. You will learn to tidy messy strings, extract features, and handle missing or inconsistent text. These skills are essential for data analysis or machine learning on real-world data. We will use the Titanic dataset for hands-on practice. Running the cell now. What are common problems you have seen with real text data? We turn off warning messages so our output stays clean. Let us set up and preview the Titanic dataset. We import Pandas, a popular tool for data analysis. Import NumPy as NP. We set the random seed to 42 for reproducibility. We provide a direct link for the Titanic CSV data. We read the CSV from the web into our data frame. We check the number of rows and columns to get a sense of its size. We preview the first few rows to see our data structure. Running the cell now. This output shows the initial shape and first 3 rows of the Titanic dataset, with 891 rows and 12 columns including passenger details like name, sex, and age. Notably, the name column contains complex strings with titles, which sets up the need for string operations to clean and extract meaningful features. This inspection confirms the dataset is ready for text cleaning and manipulation exercises. Try loading another dataset from your favorite public source. Why clean text data? Real-world data is rarely tidy. Names may be inconsistent. Some fields are empty or filled with symbols or typos. We must fix these to get meaningful results. Running the cell now. What types of messy text have you seen in the past? Let us see what Pandas offers. Let us look at some columns containing text. We print the first rows of name, sex, and cabin to spot potential problems. Running the cell now. Here we see the first 5 rows of key text columns, name, sex, and cabin. Notice how some cabin values are missing, nan, and the name column contains titles and extra details, showing inconsistency. This highlights why cleaning text data is essential to standardize formats and handle missing or noisy entries before analysis. Notice the different formats and missing values. It is helpful to know which text fields are missing. We count missing values in our name, sex, and cabin columns. Running the cell now. Here, we're checking for missing values in key text columns to understand data completeness. Notice that while the name and sex have no missing entries, the cabin column has a significant number, 687 missing values, highlighting a common real-world issue that requires cleaning or special handling. This step is crucial to decide how to treat incomplete data before analysis. Missing values can cause trouble if not cleaned first. We often need to replace missing values for easier analysis. We set all missing cabin entries to the word unknown. We display a few unique values to check the update. Running the cell now. Here we see that missing entries in the cabin or column were replaced with the label unknown, making all values consistent and easier to work with. Notice how the output now includes unknown alongside actual cabin identifiers, which helps us handle incomplete data without dropping rows. This cleaning step is crucial for maintaining data integrity in real-world datasets where missing values are common. Replacing blanks is a simple way to avoid confusion later. Text data is easier to work with if it is all the same case. We make a new column with names in all lowercase letters. We show the results for the first 5 rows. Running the cell now. This output shows the first 5 entries of the name column converted to lowercase, which standardizes the text for easier analysis. Notice how all names, regardless of original capitalization, are now uniform, helping to prevent mismatches caused by inconsistent case. This step is key in cleaning text data to ensure reliable comparisons and aggregations later on. Uniform casing helps when searching or matching text. Sometimes text columns have unwanted spaces. We create a column with white space removed at the start and end using strip. We print the original and cleaned cabin columns. Running the cell now. Here, we see the original cabin column alongside cabin_clean, where leading and trailing spaces have been removed. Notice that all values now have consistent spacing, which helps avoid mismatches in analysis or grouping. This step is crucial for preparing messy, real-world text data to ensure accurate downstream processing. White space can cause silent bugs if not removed. We often want to standardize the way information looks. Here, we swap every slash with a dash in the cleaned cabin entries. We compare the versions side by side. Running the cell now. Here we see the effect of replacing / with dash in a cabin_clean column, but since the sample rows contain no slashes, the cabin_dash values remain unchanged. This output highlights that the replacement operation is safe and does not alter clean entries, which is essential when preparing inconsistent real-world data for analysis. Notice how maintaining original values when no changes are needed helps avoid accidental data corruption. Consistent symbols make sorting and grouping simpler. We can extract part of a string for new features. We take only the first character of each cabin, which often means the deck on the ship. We look at the cleaned cabin and its first letter. Running the cell now. Here we extract the first letter from the cabin_clean column to create a new cabin_letters feature. Notice how all unknown values are consistently labeled with U, helping us handle missing or irregular entries, while valid cabin codes start with meaningful letters like C. This step simplifies analysis by standardizing cabin information despite raw data inconsistencies. What patterns do you see in these letters? We can check if a column contains certain text. Let us see if each name has to miss, which may show if the passenger was unmarried. We display the results for the first 5 names. Running the cell now. This output shows how the code creates a new column, is_miss, by checking if the name field contains the string miss. Notice that only the row with miss in the name is marked true, while others like Mr. or Mrs. are false. This highlights how text pattern matching helps identify and clean specific categories within messy, inconsistent real-world data. This helps spot special groups or filter records. Count how many unique titles appear in this named column. Import the regular expressions module to help with text extraction. Extract the title, the word after the comma and before the period, from each name using a regex and store it in a new title column. Print all the unique titles found in a title column to see the different social statuses or roles. Running the cell now. This output shows the unique titles extracted from the named column, highlighting the variety of honorifics present in the dataset. Notice the mix of common titles like Mr. and Mrs. alongside less common ones like John Keir and the Countess, illustrating how inconsistent naming can be. This step helps us standardize and clean text data by isolating key parts, making further analysis more reliable. Experiment with other patterns to extract parts of a string. Standardize rare titles by labeling them as an other in the title column. Define the list of common titles to keep Mr., Mrs., Miss, and Master. Create a new column, title_clean, that keeps common titles and replaces others with other. Display the counts of each standardized title category to verify the changes. Running the cell now. This output shows the frequency of clean titles in the dataset after standardizing rare or inconsistent titles to the other. Notice that the common titles, Mr., Miss, Mrs., Master, dominate the counts, while all less common ones are grouped under Other, reducing noise and improving consistency in the title column. This step illustrates how cleaning text data by consolidating categories can make analysis more reliable and interpretable. Grouping rare text values keeps plots readable and models accurate. Sometimes noisy data has extra digits mixed in with names. We remove every number from the name column using a pattern. We compare original and clean versions. Running the cell now. This output shows the original name column alongside a clean version, name_no_num, where any digits have been removed. Notice that in this example, the names do not contain digits, so both columns appear identical, highlighting that this step prepares for cases where numbers might exist. This cleaning ensures consistency and avoids potential errors in analysis caused by numeric characters in text fields. Cleaning up stray numbers reduces confusion and errors. Creating new columns from clean text helps with grouping and modeling. We create a new column that joins the passenger's last name with their clean title. We display the first examples of this new feature. Running the cell now. This output shows the new last_title column created by combining the last name and clean title from the names field, helping to standardize these details. Notice how combining these features into one makes it easier to spot and analyze patterns in passenger identities despite messy original data. This step highlights the importance of cleaning and engineering text features for clearer, more consistent analysis. You can build many features using text columns. Splitting text into parts is a common need. We create new columns for last name and the rest using comma as a separator. We preview a few split results. Running the cell now. Here we see the result of splitting the named column into last and rest parts based on the comma delimiter. Notice how the last column cleanly captures the surname, while rest retains titles and first names, helping us isolate key components for easier analysis. This step is crucial for standardizing and structuring messy text data, making further cleaning or feature extraction more manageable. Splitting helps when names are structured or have extra data. It can be useful to put categories in upper or lower case to keep them consistent. We build a version of the clean title where every letter is uppercase. We show distinct examples. Running the cell now. This output shows how converting text to uppercase standardizes variations in a title_cleaner column, making data consistent for analysis. Notice that each unique title is transformed uniformly, which helps reduce issues from mixed cases or typos. This step is key in cleaning text data to ensure reliable comparisons and grouping later on. Standard casing can prevent mismatches later in analysis. Recap: what you learned. You tried common string cleaning and manipulation tools in Pandas. Handling missing values. Changing case. Trimming white space. Replacing and cleaning unwanted characters. Extracting substrings and using regular expressions. Grouping and engineering new features. These skills make your data trustworthy and ready for analysis. Running the cell now. Practice. Try inventing your own string transformation or feature using the name or cabin columns and share it in the comments. Do not forget to subscribe to the channel for more Python tips. Ready for more? Explore the Pandas string methods documentation for even more powerful text tricks. See you in the next video. Running the cell now. What string cleaning challenge should we cover next time?